Hey, good evening, everyone. We'll give it a few more minutes, give it a little time for everyone to log in, then we'll get started.
Hello.
Hello.
Yeah, I have a question about the grades.
Yes.
When is the grade for the other assignment going to be posted?
For which one?
For, I believe, Lab 4.
The dual supply op amp?
Yes.
Okay. I will have those posted by the end of the weekend. I went through and I didn't see all this, everyone having them turned in when I did the first lab. So I'll start updating those. Um, provided we're going to go over it tonight, but provided you hit like these three areas right here, the hand equations, screenshots, and measured waveforms, more likely you're going to get full credit on each one.
Okay, thank you.
All right, we're 5 past the hour. Let's go ahead and get started. All right, welcome back, everyone. Tonight will be the last night of Triple E 108 Lab. Couple of housekeeping things. All lab reports will be due next week. So this on Thursday, which is December 17th at 9 p.m. So if you're still working on some of the previous ones, that's fine. There's three labs: the introduction op amps, the dual supply op amps, and the one we're closing out tonight, which is the BJT biasing and amplification. All three of these are the ones that require a submission. For report content, really what I'm asking for, and it's pretty loose to be honest, is to show your hand calculations. Completely fine. A couple of students have taken cell phone screen captures, things of that nature, and embedded them in a Word document. A screenshot of your piece by schematic, just to show you built it up. Then the last one is, a screenshot of one of the measured waveforms. It doesn't have to be every single one. Or I guess what I should also put in here was a picture of the circuit you built up on the breadboard. And I'm going to include this in an email that I send out since not everyone's in attendance tonight. Last, a question was brought up about grading. I've gone through about a week ago, and I assigned grades to those lab reports that were submitted at that point in time. Because of COVID, we're keeping everything open until the end of the semester to permit flexibility in case, of illnesses or anything along that nature that bogs you down. So hence the deadline in next week to get all the labs turned in. So next week on Friday, the 18th, I will sit down and go through all the labs, assign grades to them. To be direct, provided you hit these content bullets right here, you're going to get full credit on the report. You gave an honest effort, and you'll be in good standing. Then I will post your final grades shortly after Sac State opens the faculty portal, which enables me to upload your grades. The last thing I want to talk about before we jump into the final portion of this lab tonight is the analog discovery kits. When those were initially mailed out to you, hopefully you still have it, as a shipping label was included in the kit. We're going to need you to return those as soon as possible upon completion of the lab, so that the lab techs can go through and make sure that there's an ample amount of components in there, everything's working fine, and that they can turn around and mail it back out to the next group of students for the
I got a
spring
question
semester.
about that.
Yeah, go ahead.
Are we able to like drop it off at school?
That's a good question, Rodrigo. I'll tell you what, let me email Professor Headley and ask him about that. You might be able to drop it off at the department office. I will send him a message tonight, and he's pretty good about responding right away, so I should have an answer for you by tomorrow. Does that work?
Okay, thank you. Yeah, I was just wondering in case someone didn't want to like mail it in or something, if that was just
Okay.
easier to go to the school.
Oh, I'm sure they'd appreciate that. I mean, it enables the lab techs to get on a little bit quicker and do an evaluation of the kit and get things, back out. So the last thing with the kits, I posted it on the Moodle site. Let me pull that up real quick. There's let's see here, minimize these guys. There is a checklist, and I'd appreciate it if you could fill this out, whether or not you mail it in or drop it off. And if there's anything that may be used in the kit, sometimes leads break off of components and they're not usable anymore. Or if you had some issues with your Analog Discovery 2, if you found that some feature wasn't functioning appropriately, or one of the power supplies, like, calls I hear, wasn't working, please list that in here. And just email a copy of that to Professor Headley at this address right here, since he's going to be the one collecting all this information. In terms of the Moodle site, again, I'll include this on an email, but let's see here. Let me go back to the Moodle site, if it'll let me. On the Moodle site, I posted that document right here under the Digital and Analog Discovery 2. It's the AD2 pivot kit return checklist right here. So again, if you can fill that out, I'd appreciate that, and get that to Professor Headley. All right, so for tonight, let's go back. We're going to finish up this BJT lab here. Hopefully, things have gone well for you in terms of performing the preliminary calculations and SPICE simulations. One thing I want to point it out, unfortunately, as I've said many times already, these labs were set up for you to be in the classroom, right? And to use a VCC at 10 volts. Unfortunately, tonight, while building the circuit up and running it through some of these steps, I realized that you cannot achieve the specified current of 500 microamps with a 5-volt supply. I'll show that to you real quick. Let me go to Edit, Simulation Profile. I'll do a DC sweep right here. And we'll just look at, I'll put a current probe right here for you so you can see that. Let's see here. There we go. All right, let me run this for you. So recalling the lab, initially what they wanted you to do is build this circuit up, ignore the capacitor and the function generator, the sine wave source for right now. We're not going to use that. But they want you to build this circuit up with these three resistors, your collector, emitter, and base resistor, and set this supply right here such that you had 500 microamps of current coming through your collector, right? Well, there's a problem with that, and that is, let this run up here. You'll see as I sweep the base voltage, which is V1, you never achieve 500 microamps of current, right? It saturates out at about 420, just shy of 425. Therefore, what I'm going to recommend, and I apologize if you've already attempted to build up the circuit and run into some headaches, but this is your linear region right here, right? So what I'm going to recommend is pick a bias voltage so you're right at like 200 microamps, because that's roughly right in the middle, give or take. I mean, if it's 200, 205, 210, that's fine because it's going up to about 420, right? So going back to the schematic, that's what I've done. I selected a base voltage here. You'll see, let me do a bias point sim for you. Let's see here, change, we're gonna go back, do a bias point, and let's see here, we got current turned on, that's good. All right, run the simulation, and we don't care about the plot. Let's go back to the schematic. So yeah, 207, so it's about right in the middle, right? 200, a little shy of 210, that's close enough. So that's going to permit you enough headroom to swing up and swing down as an amplifier. So the next step, going back to the lab, once you get to the buildup of the circuit itself, you're going to have this circuit here, and you're going to connect the function generator, right, with a capacitor, a 10 microfarad capacitor, and you're going to drive a 200 millivolt signal into 10 kilohertz into this circuit. Then you're going to look at the amplification of it as one of the steps. So if I come back here, let's see here, and actually it's 200 millivolts peak to peak, and I know this is the peak value, so I'm going to change this to 100 millivolts peak, so you get 200 millivolts peak to peak. And let's come up to PSpice. Connection's a little slow tonight. I'm gonna edit my simulation profile. I'm gonna do a transient sim so we can look at the time behavior. So let's think about this, 10 microseconds, that's 100 microseconds per period. We should look at 5 periods, so that's 500 microseconds of runtime. I'm gonna do a maximum step of 1 microsecond. Close that out and run the simulation. And here you go. Looks like I missed one of the, sorry about that. One of the voltage markers that I wanted to put. Let me come back here, put one here on the source. There we go. All right, so now we got our two signals, right? We got, this is your collector, this is your base, so this is your 200 millivolt peak to peak. One thing I want to point out here, we weren't in a lab really to go over this, but, well, we weren't in a lab at all to go over this. This would be an example of DC coupling, right? So your base signal is at 0 volts, and you got 200 millivolts peak to peak, this red one right here. Whereas your collector is at, this one's about like what, 3 volts? It's about right in the middle. Yeah, 3, maybe a little less than 3. So this is DC coupling. So you're getting the DC and the AC component of the signal. If you're to do only AC coupling with your measurement, again, I'm trying to mimic what you're doing with your measurement equipment right now, just to show you what you should be seeing. Both of these signals would be superimposed on top of one another. Another way, if I wanted to do that, just to mimic that signal, what I could do is I could come in here and copy this capacitor like such. And hopefully this will let me do it this way. But I could do something like this, possibly. Let's see if it works. So again, I'm just trying to do the AC coupling portion of it. No, it's not going to let me do that because it doesn't like how this is floating. All right, so I'm going to delete that. But I just wanted to show to you, and again, this green marker just helps highlight where the error is. The difference between DC and AC coupling. So you see your two signals coming out of the circuit. The last thing I wanted to touch on was going back to lab step 13. They want you to replace the source VBB and the resistance RBB with a voltage divider network. Okay, so they provide you with some parameters, right? You have R1 and R2 such that RBB equals 22K plus 4K. Then again, shoot for 0.2 milliamps or 200 microamps, not 0.5, since you're limited to a 5-volt supply. So what do they mean by a voltage divider with two resistors? Well, if you're a little confused on that, here's what they want you to do. I'm just going to copy this entire circuit here and show you. Drop this one over here. All right. So what they want to do is have you come in and get rid of this voltage source and delete that. And they want you to create a voltage divider like such to where you have two resistors. They're both connected to VCC. And finish the connectivity portion of this here. So why would you do that first of all? It's a good question. Would be typically, again, imagine like if this whole circuit's operating off of one battery, right? You got like a 5-volt battery driving this whole thing. Well, you're not going to have a 0.9 volt battery to create this voltage for the base. So how are you going to get this base voltage up here, which is 820.5 millivolts, with only using this 5-volt source? So that's where this voltage divider comes in. So you're going to use two resistors, and here I just got them labeled RBB1 and RBB2. You're going to have your 5-volt supply, and you're going to have to pick two values here of your resistors such that you get the right voltage on the base, correct? Then the report kind of gives you some guidelines on the resistance calculation conditions, right? So let's go back to that real quick. So they want it to be such that RBB equals 22K plus or minus 4K. So you might be asking, well, what do they mean by RBB being 22K plus or minus 4K? Well, that's going to be what the impedance is looking into this node right here, okay? So looking into this node right here, the impedance is this resistor and this resistor in parallel with each other. So one condition is you got to have the parallel combination of these two resistors be 22 kiloohms plus or minus 4K. So it could be anywhere between 18 and 26 kiloohms, all right? So as you can see right now, I don't meet that condition. Parallel combination of these two resistors would be 11K, so I'm well below that. So clearly you need to bump that up and make it larger, right? Then the other condition is, that's just the resistance part of it. The other condition is you got to have the voltage divider equal the right voltage, right? Which is 820.5 millivolts to get you that 200 microamps of current coming through the circuit. So to do that, you have a second equation. You have RBB1 divided by RBB1 plus RBB2 times 10 volts. That's just your classic voltage divider equation, right? To get the voltage on this base right here. So you have two unknowns, your two resistor values, and you have two knowns, which is the two equations equaling either the voltage or the impedance constraints, and you use that to solve for what your resistor value should be. I'll leave that to you. I'm not going to plug that in right now, but when you build your circuit up on the last step, you'll essentially, you're going to pull out this resistor here, and you're going to put this parallel combination in here. You're going to have this 10 microfarad capacitor hooked up to your function generator, and that's what's going to be driving your circuit to provide the output. Let's go back to the lab report and see if there's anything else. Okay, so that's step 13. And from there, you can get the small signal gain, which is really just you can take the peak-to-peak value of the collector voltage over the peak-to-peak value of the base voltage, right? So that's your delta V out or over delta V in to get your gain. Going back to step 12, this is pretty similar to what you've done in the previous op-amp labs. You're going to increase the AC signal amplitude, so the peak-to-peak coming out of the function generator until you see clipping on the output at both peaks. So both the positive and negative peak. And that pretty much wraps it up. Let's see here. I'm going to jump back now to pull up the chat area to see if any questions popped up. So I'll open it up at this point. Do you have any questions regarding either specifically right now for the final lab, the BJT lab, in terms of any difficulties with the hand calculations, the simulation results, or if you've attempted to build up the circuit? All right. If not, and I understand if you haven't got to the circuit part of it yet, if you encounter any difficulties over the next week as you build the circuit up, shoot me an email. I'd be glad to, help you troubleshoot it, work your way through it, or add clarity to any of the directions that are provided within the lab report itself. Do you have any questions pertaining to any of the previous labs or anything for the course itself? All right, I guess one question would be, I just want to make sure everyone can hear me. Can you hear me?
Yeah, we can hear you.
Okay. All right. That's all I have for you then for this evening. If there's no follow-up, that concludes the end of the lab sessions for EEE 108. Hopefully the semester's going well for you. I'm sure you got finals coming up in a couple of weeks. Good luck with your preparation for that. And hopefully see everyone back on campus at some point in the future. Hopefully things open back up again. Normally it's really awkward with COVID. Normally I had the opportunity to talk to people in class and inquire on an individual basis about, career aspirations or what fields of electrical engineering that you want to go into. I have a LinkedIn account. You're more than welcome to connect with me through that. If you have any questions in regards to, I know a lot of you are going to be transitioning into your senior year and you're going to have to make a determination on like what route you want to go and what you want to focus on. If you have any questions about that or specific career paths or anything like that, you're more than welcome to reach out to me anytime. I'll provide you with some advice, or if it's an area that's outside of my depth, if I know someone that aligns with that field, I'd be more than happy to connect you with that individual to provide you some insight to working in that area. So yeah, feel free to reach out. If nothing else, have a great end of the semester and winter break, and best of luck with your spring classes.
Thank you. You as well.
No problem.